What's shaking, grade 9? Getting lonely here without you guys. I'd like to see and hear from you. It'd be nice. Starting to hear voices, so just got to snap out of it. We're moving on to 4.3 today. Similar triangles. So in math, when we talk about similar shapes, it's not like in life when two things are similar, they have something in common, like Matthew and Sierra have a lot in common, right? But it's more, it has to do with the angles and the sides, right? So when two things are similar in for example, a triangle, that means all of the angles are the same in the two shapes, and the sides correspond with the same relationship. Okay, so that's what we're going to take a look at in this section. So we're going to be using some of the skills we learned in 4.2, or we're using in 4.2, and we're going to apply them in a triangle. So one of the things we're going to be asked to do is identify if two things are similar. So we basically check that the angles are the same, and then we check that the relationship between the corresponding sides is the same. And if it's the same for all three corresponding sides, then we've got a similar shape. Okay, so here we can take a look at this example. We've got a 90-degree angle and a 90-degree angle. Those are corresponding. Then we've got a 37 and a 37, which means if those two angles are the same, these last two must be as well. We can figure out what they are, but we don't really need to, but we know that the angles are the same. So the only thing we have to check then to see if they're similar would be checking the 4 and the 12. Okay, so whatever you get when you divide, and so that's going to be the skill to do, is divide the one number by the other. In this case, it divides nice and evenly. It should be 3. That means every time you divide a corresponding side, it should equal 3. And if it doesn't on all three, we don't have a similar shape. But I think this one's going to work out. 15, if I divide 15 by 5, those are corresponding. That also gives me 3. And if I do 9 divided by 3, that also gives me 3. Okay, so that means, yes, it is similar. Okay, so you just have to check the corresponding sides if the angles are already the same. Okay, so a couple more examples here we can run through. This is the show you know. This shape, they're kind of like a mirror image, so we always have to make sure we're taking actually the true corresponding sides. So if this is the angle, and this is a 69-degree angle, then these two sides here are corresponding, the 1.7 and the 1.1. So that should be equal to the same thing that you get when you divide 4.5 by 3, which should be equal to 4.2 divided by 2.8. And it has to work for all of them. It can't just work for 2, it's going to work for them all. So let's just calculate this for a minute. 1.7 divided by 1.1 gives you 1.54, and it looks like that's going to keep repeating. If I do 4.5 divided by 3, it gives me 1.5. It's very close, but these are not exactly the same. So I already know that it's not similar. I can check that last one as well if I want. This one's also 1.5. So these two sides correspond, but this last one is slightly different. So no, this one is not similar. Okay. Next one here we've got, we do have to be careful here. Here's the 70-degree angle. And here I've got a 2.7 and 2.5, and then a 3 and a 4.1. So I want to make sure that I'm actually picking the right corresponding side. So it's got to be the two sides that are on the same, on either side of the 70-degree angle. So for me, I'm going to take 4.1 and 3, and it should be equal to what I get when I do 2.5 and 2.7. Okay, so assuming I've done this right, this is the bigger one. I already can actually tell 4.1 divided by 3 and 2.5 divided by 7. This is a bigger number divided by a smaller one. This is a smaller divided by big. So I actually know already that this is not going to work out. So you could calculate it for yourself. But these ones are not similar either. Okay, so it has to work for all three. Okay, example 2. Kyle is drawing triangles for a math puzzle. Use your knowledge of similar triangles to determine if they're similar, and then determine their missing side length. So if they're similar, then the side lengths will match up. So if the angles are the same, that's how I'll know if if the angles are the same, then I should have something that matches up. So here I've got an 85. If I've got 85 and 50, I can use what I know about angles in a triangle, namely that they should add up to 180. That tells me that this missing one is 45. These two, I know that if that one's 45 and 80, then that one's going to be 50. So these do have all the same angles here. Okay. So then the other thing I have to check then is is the relationship going to be the same here? So if I take the 24, that's the side that's in between here. 24 should be within 8, and then 21 and 7. And sure enough, we can do some simple math. That's actually going to give us two nice whole numbers. Both of those are equal to 3. So because the angles are the same and because the side lengths seem to be matching up, then it looks like that these two triangles are similar. So if they're similar, then I can use kind of a cross multiply and divide method again to actually find the missing side length. So if I have this side length and this side length, and then I can compare that to either one. I can use the 24 and the 8, right? 24 with the 8, or I could use the 21 and the 7. And actually, either way will work. I could cross multiply and divide with this one, or I could cross multiply and divide with this one. What I should keep in mind is that on the top of all these fractions are the same triangle, and on the bottom would be the smaller triangle. So make sure you're not mixing this up and doing 8 and 24 instead. Okay, so if you do that, you should be able to cross multiply and divide. So here I can do 10.5 times 24 and then divide by 8. Gives you, I believe, 31.5. Okay, hopefully there's no questions there. Moving on just to the last show you know here. So solve using a method of your choice. GHI is similar, so often the questions will tell you that these two things are similar, and then so if you know they're similar, you can use a cross multiply and divide method just like in 4.2. So again, if I look at my corresponding sides, I'll just take x and 10. These are corresponding. So x divided by 10 would be the same as, and I can take my pick. I can use whichever one I want. I'll just use the 1.9 with the 7.6 here. And again, I should be able to cross multiply and divide and find my missing side length. Okay, 10 times 1.9 divided by 7.6. So when you're cross multiplying and dividing, don't forget to divide by the remaining. Okay, this one's a little trickier because it's in one diagram actually. So we've got kind of the big triangle and then the small triangle. I think it's easiest if you just split this up into two separate pictures. So I've got the x value here on the big triangle. Then this side length I could figure out. It's just 7.2 plus 8.7. Okay, so that's 15.9 for the big triangle. And then same thing here, that's 19.2 I believe, when I add these two up. So I've just drawn the big triangle separately. Then I have my small triangle here. And so these two, it tells me, are similar triangles. So then determine the missing side length. So now that I've filled it out like this, I can now do the exact same thing here as if I had two separate triangles. I just have to take the corresponding sides. So x over 5.4. And I'm just going to pick one of these. I don't need to use both. I just need to pick one. I'll take 15.9 on the bottom with 8.7. And again, cross multiply and divide is going to be the skill of the day. If you can master that and you can set it up properly and make sure that they're the same, you should be able to get your answers for these. Okay, so there you go. Cross multiply and divide. You should be able to work your way through some of these questions on page 150.